Yeah, good morning, everyone. And thank you, Phil, for allowing me to present some of our experiences and approach to integrated project delivery. My name's John Lohan, and I'm a partner
Is the
with
audio okay?
IPD. The IPD team's experience in unlocking value is based on delivering differently, and our efforts span nearly 25 years across a range of projects, from minor to mega, and across a broad range of sectors. This presentation is going to dive into an example of the integrated production models we develop and use. I'll then outline the benefits of the approach through 3 case studies and round off with 6 key lessons that we learned. We believe that to achieve significant improvement in project delivery performance, we need to deliver differently. The starting point for this is to clearly understand the client's vision and define what value looks like for them. Here we consider the business and project objectives and start to shape a suitable delivery approach based on our integrated production strategies and toolkit. A key element of our model is enabling the right environment. This means deploying the right leadership with a firm commitment to the vision and a relentless focus on delivering client value. The 9-box model tools can be used independently, but they function best when combined to create what we call an integrated production system. We talk about client value, and this slide sets out some examples. In the GSK example, it was about delivering medicine to emerging markets with numerous issues, including immature and unpredictable supply chains and the potential risks associated with poor local health and safety performance. In the case of Swansea Tidal, the client needed to improve his business case by generating energy as early as possible and thus minimizing construction and commissioning schedule. The Northern Water example was about delivering in a remote and harsh environment where your nearest screw fix is 1,000 kilometers away. In this case, planning and organization to a greater degree than norm was critical. So this is an example of a production system we configured and used to deliver several major civil engineering projects and programs. The red line is important. It identifies when we normally stop spending thousands and start spending millions. To the right of the line are the field activities, the place where we burn significant cash. It's where we make or lose our money, and it's where projects succeed or fail. We talk about going slow to go fast, and what we mean by this is that the more quality time spent on the left side of this diagram, the faster the right side will perform. Typically, people costs can equate to 50 to 70% of a project cost, and improving their productivity is a key factor in being able to do more faster, or perhaps the same with less. Using the production management strategy, we seek to improve site production reliability. This in turn improves our supply chain demand signals. Through close collaboration with the supply chain, we develop various approaches to ensure products flow to the right place at the right time, to the right quality and in the right quantity. We define, design and continuously improve supply chain processes to reflect the differing strategies required for bulk materials, made to stock products and engineered to order products. Examples include the design and implementation of pop-up factories to manufacture and prefabricate products, to the implementation of Kanban systems with min-max stock holdings, which ensure we always have the optimum stock available to maintain planned production in the field. A critical element of the production strategy is production control. This is where we develop a system to shield the site from the classic problems incurred on projects. For example, late or incomplete information or materials, too little or the wrong type of labour resources and availability. We focused intensely on the MakeReady process for each element of work, building work virtually in pre-validated information packs, ready to release. These strategies improve system reliability and allow improvement to allow us to improve our ability to pull product through the supply chain in a predictable manner, allowing us to adopt just-in-time approaches and minimize work in progress being delivered to site early or in the wrong sequence. The approach engages and leverages the workforce experience. Input could typically be safety, sequence, or buildability related, but it's captured through the use of digital tools. Ultimately, work packs contain assembly instructions, pre-planned optimal assembly sequencing models, visual risk assessments, etc. As an example, on the @One program, they've taken this to another level, and as part of their overall governance process, they introduced a requirement to virtually build projects in totality before releasing to the field. On mega projects, daily expenditure can be significant, often 10 to 15 million pounds per day. Without a production system, it's often difficult to identify issues and their root causes, which are causing failures at the workplace. Through daily measurement of root cause issues, problems can be identified and resolved quickly. As an example, lead times for design information were 6 weeks, and the designers weren't able to provide sufficient information to maintain progress at the workplace. We undertook a collaborative process review with the design and delivery teams, seeking to remove non-value-adding activities, unnecessary process steps, and the result was to reduce the lead time from 6 weeks to 6 days. Other benefits included increasing value-adding design capacity and allowing more time for the MakeReady process. The production management system provides exceptionally detailed performance data. It changes team behaviours and their approach to planning, encouraging people to break down tasks and plan at a more detailed level of resolution, and ultimately this improves reliability. The adoption of standard processes, which are adopted across the project, incorporating design, manufacture, delivery, and assurance, also creates greater transparency and facilitates easier problem identification, and therefore improvement, and again, improving production outputs. In the case studies, in terms of case studies, I mentioned Swansea earlier. The key driver for the client was speed to energy generation. On this project, we used DFMA and offsite manufacturing strategies for the civil and mechanical elements to enable schedule reduction. Designing to a greater level of detail, as is required by DFMA, de-risks the project and improves certainty of outcomes. Adopting a DFMA and standard product approach also introduces more constraints at the project level in terms of change, sequence, etc. These potential issues are counteracted through creating more flexible and mechanical supply chains designed to be able to respond easier and faster to change. The design approach sought to maximize the design approach in this case sought to maximize environmental and local society benefits, and part of this was engaging with the existing UK supply chain whilst building new local capability and capacity to deliver this and future work programs. Despite 10 years of planning and investment, unfortunately, the project hasn't yet made it into delivery due to political constraints. The integrated approach to design, manufacture, and assembly developed by IPD in collaboration with Robert Bird generated the following potential benefits when compared to the previous iterations of design and delivery strategies. Importantly, we were able to achieve power run in 36 months rather than the originally anticipated 60. This was a Queensland gas project, otherwise known as a fracking facility, located in the outback. The nearest city was 450 kilometres, which was Brisbane. There were two almost identical projects. The first was built traditionally, and due to delivery failures and cost overruns, the client sought to adopt a DFMA and offset manufacturing approach to this one to, again, mitigate and reduce the potential risks that he'd already incurred. The project was a mixture of heavy civils and heavy mechanical engineering. Modules were delivered, prefabricated, stores, containers accompanied them with all the necessary bolt sets, equipment, PPE, and that required to complete the work package, i.e. a kit of parts. Benefits included reducing requirements for the on-site workforce and delivering delivery on time on site reduced from 105 to 63 weeks. And again, the results speak for themselves, but a real benefit for me of adopting DFMA and offset manufacture is the focus on upfront planning and organisation, which then supports improved performance downstream. Designed for productivity, if you like. As an industry accustomed to transferring the risk of productivity, and as a result, we've to a greater or lesser degree lost sight of its importance. It's stating the obvious, but it's worth remembering that it directly impacts the time it takes to deliver projects and ultimately directly impacts the outturn of cost of projects. The final case study was a project I led. The challenge faced by the client was to de-risk delivery of small-scale, flexible pharmaceutical manufacturing capability in emerging markets with differing local challenges, whilst also seeking to optimize cost, time, risk, and quality performance. Other client drivers included adopting a platform approach to designing and delivering the project, and they required the following features to be embedded in the system. It was necessary to be expandable, adaptable, repeatable, high quality, inherently safe, efficient, rapid, cost effective, assembled, not constructed, and fully transparent. Working with Bryden Wood, we adopted this platform approach and developed a configurable kit of parts and assemblies. Standard designs were used and reused. We termed it content creation and content configuration. Project locations were anticipated to be in challenging and varied environments. The platform approach allowed projects to be sourced globally as pre-engineered solutions and installed by local labour in accordance with the system assembly instructions. We worked to a desired budget and collaborated with the designers and the supply chain, adopting a design to value approach to ensure the works were delivered within the client's cost envelope. Having iterated the design to reflect the optimum operational maintenance, assembly, logistics, and manufacturing processes, we then set to work delivering it with 6 general operatives. One of the objectives for the project, a lot of objectives I know, was for it to be easier than IKEA. This requirement was achieved through everything being either plug and play or bolted. No drilling, no cutting, no welding, and no rework. We expended 18% of the project resource budget on training. We used accelerated learning, bringing in staff to demonstrate and oversee the implementation of the next task. Whilst this looks like a considerable investment on the face of it, the upside was that it removed all the traditional trade interfaces, and this allowed us to adopt a more agile and flexible approach to delivery. So, lessons learned. Adopting isolated tools is good, but if you want to create step change, you may need to consider the IPD approach. Strong leadership and commitment is crucial. No bending or turning back. Early collaboration with those that make and do stuff is essential. Adopting a production system that creates transparency and simplicity across the delivery approach. It allows measurement of the system performance and facilitates improvement. We all need to be continuous improvers. Adopting a 3D visual approach to design is essential. It's often not the product that's most important, but the interfaces between them. Layering data into the model and then reusing it for multiple purposes through design, manufacture, and logistics is essential. And creating the environment for open and transparent engagement with the supply chain is critical. That engagement needs to be meaningful, structured, and formal. Our production system seeks to create a flow, a steady state. It seeks to deploy resources in factories where consistency of approach can be more easily achieved. It seeks to reduce the on-site resources and the delivery durations and the associated time-related costs, aka prelims. It creates greater transparency through integration, collaboration, and a focus on simple but effective processes. This concludes my presentation, and thank you for your time. If you'd like to learn more, please don't hesitate to contact me via LinkedIn. My name is John Lohan. Thank you very much.